Thank you. All right, perfect. Thank you so much, Dway. And thank you for having me. So in my talk, I'm going to talk about some of the recent developments we see in people analytics and link them to maybe algorithmic fairness. So in the beginning of the talk, before transitioning into pay equity and how analytics can and can't support organizations in reaching fair pay. So if we kind of think about analytics over the past decades, we have seen analytics revolutionize every aspect of the organization. And now we are really witnessing an explosion in the availability and application of analytical tools in the HR space. And I think the potential of these methods is really undeniable. And in my mind, there's a huge opportunity for Inform's members to have a significant impact in this space. So I'm super excited to share some of my thoughts on people analytics. So one thing to keep in mind, especially as Inform's members being trained in supply chains and operations, you cannot simply translate the analytical approaches from accounting or operations over to the HR department. What is so critically different is that in contrast to, say, determining the right stock levels or which brand of ketchup to put on sales, with full acknowledgement of the amazing, mathematics that go into making those decisions. However, the decisions that are supported in the HR departments can have instrumental impact on employees. So if you think about who gets the job, who receives a promotion, who is identified as a promising employee, each of these decisions can have a life-changing impact on employees. And therefore, we need to be super mindful of how we apply our analytics in this space. So what is then people analytics? I really use people analytics and HR analytics kind of meaning the same thing, but really what we're talking about is supporting the HR departments, perhaps the comp departments, in their decision making. And if we take a look at the OR/OM literature, really the first problem that we looked at was employee churn. So if you go back and you kind of review the people analytics literature, one of the first papers is, what is our expected churn? How many will leave the organization within the next 6 months or 12 months? And then how many do we need to hire? However, people analytics as a field has kind of exploded, and we have gone way beyond what I call maybe simple regressions. And now when we think about employee churn, we're not just taking in, okay, this department, how many leave on average, but we're really using big data to create employee profiles to figure out, okay, who is at risk of leaving. So you can think about organization looking at communications and when code is submitted and how people work together, all to create alarms about who might be of risk of leaving. So let's say someone who is constantly emailing after 9 p.m. at night, or somebody who is submitting code every single weekend, right? So these can be signs of employee burnout. So we are really similar to what we observe in the healthcare. We're moving to personalized medicine, and the same thing is happening in people analytics. We're moving away from these broader models into how do we personalize them to make better use of them. Another big field of people analytics is understanding the organization. And here, where we started was really just building a network. So you can think about taking all of the email conversations that happen within an organization and simply plotting who emails whom, right? But now, when you think about, okay, where have we moved from there? We can now, for example, embed sentiment analysis. So then this is taken at a conference called the Wharton People Analytics Conference in 2019. What they had done here was to, yes, take this network of employees and look at, okay, who is talking to whom, but they have also embedded sentiment analysis. So who are your happy employees? Who are your less happy employees? We can see here in the lower left-hand corner that there's some really group of unhappy employees, and then take proactive action. Another exploding area of people analytics is targeting the right applicants or hiring the right applicants, or in other ways supporting the hiring process. And here, I would say maybe the startup world has kind of moved way beyond the academic research. So this is just an example of one of the promises that one of these startups makes. They claim to predict, and I'm just reading off the slide. So they claim to predict the performance and cultural fit of applicants before you meet them, using the signals of career success in the innovation economy, so grit, teamwork, impact, etc., right? And the stories are endless. And when I said that, maybe the startups have kind of moved beyond where the research needs to catch up, I think what we're increasingly seeing is some examples where, people analytics have gone wrong. So my first example of that is this example of a commercially available tool that uses AI to analyze your tone of voice, your language, your gestures, and your facial expressions, all to create a behavioral personality profile with the goal of speeding up the candidate screening. And they claim to deliver a more objective, fair, and faster recruiting process. However, when BR News in Germany actually dug into this tool, they found that the scores from this tool were significantly impacted by simple props, such as wearing glasses or a headscarf. Further, the video background equally impacted the behavioral score. Another example, and perhaps the most famous example of biased analytics in the HR domain, is the internal tool that Amazon built to screen CV of applicants. So it's not all just startups. Amazon is known for their amazing analytics. However, in this case, they built their tool on past employee data. And since in the past, their successful employees were mostly men, the tool identified traits that are associated with men as indicator of success, to the extent that the tool penalized CVs that included the word woman, as in, for example, the captain of the women's chess club. It also downgraded graduates of 2 all-women's colleges. So that's just example of what can go wrong when we apply analytics in the people analytics domain. And one thing I also wanted to mention in my last example of kind of people analytics gone wrong is sometimes the answer to this is not, oh, we just had biased data. So a recent study by Lambrecht and Tucker, published in Management Science, highlighted how an ad for STEM opportunities that had been carefully designed to be gender neutral ended up being shown to disproportionately more men than women. And the reason was that the algorithm was optimized to maximize the cost effectiveness, and then try to show the ad to as many people as possible. But it turns out that on social media, the eyeballs of women are more expensive than the eyeballs of men. So the algorithm showed the ad to more men than women. So these are just 3 examples. So what is critical when we build analytical tools in the HR space is to be aware of the multitude of ways in which biases can creep into our models and therefore into our decision support. So I just want to spend, before I dive into my favorite topic of pay equity, just to spend a few minutes talking about our analytical process and how we typically conduct it and how it needs to change. So, us that have been in this for a while now, what we learned was, that we have this objective process. So we, have the data, and then we build some models, and there's an outcome that supports our decision, right? And while this process may appear objective, it's filled with human judgment and potential pitfalls. So, for example, data biases can stem from multiple sources, both direct biases. So think about bias performance evaluations when we include that in our compensation models. There can also be indirect biases stemming from the use of proxies. So such as using the grade point average as a proxy for intelligence. But as we know, grades are, for example, influence whether you have to work alongside school. So in the context of people analytics, and any model that we build in this space really is therefore very important to understand when we use proxies, because not everything is directly measurable, whom does that benefit and whom does that hurt? And again, kind of thinking about our HR data, which comes from our organizations, because demographic groups, whether we are looking at gender or whether we are looking at race, are not equally distributed across the organization, our data that we build or the data that we use to build our people analytics tools is always imbalanced, right? So for example, we may not have an equal gender distribution at the management level. We may not have equal race distribution across functional areas. And therefore, when we start building our machine learning algorithms and they start interacting with our unbalanced data to support, for example, the identification of employees for opportunities, they can create inequities. So for example, some of the things that we might want to keep in mind is that when we run kind of off-the-shelf algorithms, right, which we typically do, right, we might be doing this in R or we might be doing this in Python, but it's just one function and we run our model. But when we do that, and when we do that on imbalanced HR data, what we need to be careful about is first that models will typically perform the best for the majority group. Because that's literally what the algorithms are doing. They're maximizing the overall performance. And since the majority group is the biggest, the models will work the best for the majority group. Another kind of easy shortcut sometimes mentioned is, we'll just simply remove all the demographic variables, and then by magic, our models will become gender blind or racial blind. However, in HR data, there are always underlying correlations, so that suggestion will fall flat on its face. And third, and again, kind of related to this notion of representation in our data, if our data is not balanced, even carefully built models, so we are aware of this and we are very careful in the way we build our models. Anytime we are facing this unequal representation, when we build these models, it will not lead to equal outcomes across groups. So for example, if we are in a company where most managers in the past have been male, a well-constructed model that identifies future managers will be more likely to falsely identify male employees as management candidates compared to the females. So similarly, the algorithm is more likely to miss deserving female candidates. So for all of these reasons and others, it's therefore very important that we apply what I call a bias-aware analytical process. So that means checking our data for bias, that means checking our models for bias, making the corrections if we need to, keeping the human in the loop when we use these models to make decisions, monitor the performance of the model when it's both on past data and when proactively when we apply it, and we need to be aware of feedback loops. So so I think my main message here, given that this is the DEI seminar series, is that blindly applying data models, no matter how sophisticated the machinery, is that they can have unintended consequences. So it's critical to be aware of these biases, etc. And if I have a whole paper on it, Google it or email me if you're interested to read more about this. But it's hopefully I've taken this 10 minutes to explain that it's super important to be mindful about all of these potential issues. And before, I think, moving on to my pay equity, my favorite people analytics topic, I want to leave you with this one thought that when we think about people analytics, it's super important to remember that our HR data represents the past. And in contrast to so many other analytical applications where we can go and collect more data, we cannot go back in time and hire a more diverse workforce. And therefore, as we build towards these equitable workplaces of tomorrow, we need to carefully consider what is missing from our data and upfront determine how those and other considerations are going to be accounted for in the decision-making process. And then we can really start to maximize the potential that analytics have in the people analytics space. So I'm going to leave it there. That's my cautionary tales portion of the program. And move on to where I have spent my, I would say, past 5-6 years focusing on within this, within the field of people analytics, which is on demographic pay gaps. So how do we use data and analytics to support organizations in eradicating their pay gaps? So when we think about pay equity, maybe there are two important things to think about. There are really two types of pay gaps. And people talk about them kind of interchangeably. There's the absolute pay gap, and then there's the equal pay gap. And the absolute pay gap, that's the 82 cents on the dollar that Obama talked about, President Obama talked about multiple times. That's literally the difference in average pay. Then the other notion is this notion that is based on this fundamental of equal pay for equal work. And that's what's called the adjusted pay gap. So after accounting for your job selection, your performance, your tenure, whatever it is that should drive pay, are there any differences between male and females, between racial groups, etc., within your organization? And that's really going to be the focus of my talk today. How do we support organization in eliminating their equal pay gaps? And we have all seen, the news come in almost every day about, there's a gender pay gap. So whether it's in Hollywood or, amongst workers in Australia or Glasgow, Scotland, we are bombarded by these news, and the legislative organizations, the parliaments, etc., have taken, notion and are thus driving change. So I would say over the past 5, especially the past 5 years, maybe past 10 years, there has been a change in the laws and regulations almost everywhere. So equal pay for equal work has been on the books for decades. So, the middle of the last century. The problem is that those laws, the equal pay for equal work, didn't really have any bite. So what we have been seeing is really the whole landscape behind equal pay is changing really fast. One of the changes that is happening is that we are really moving away from equal pay for equal work. Because if it's literally equal work, who does exactly the same work? Almost no one, unless you're standing next to each other on an assembly line. So the legislation is really moving towards, now they typically read substantially similar work, and then they mention which factors you're allowed to use to determine whether things are similar. We even see, for example, in Sweden, at the federal level, in Canada, they are moving towards equal pay for work of equal value. So it's not even about are they doing similar work anymore. It can literally be, here we have two people, they're doing very, very, very different work, but is of equal value to the organization, and therefore it should be compensated similarly. So that's a trend that we see increasingly, less so in the US, more so in Europe, and for example, Spain is moving towards that direction. Another trend in the legal framework is that really they're just starting to build in and legalize best practices. So, for example, not being allowed to ask for your salary at your former employer is becoming almost standard. And then transparency is another big push happening globally. And there, it can take many shapes. So whether that's making it a requirement to post the salary range for a position when you advertise the position, to anything over to publicly announcing your pay gaps. So that's actually the direction that the UK took. So that's the example that I included here. So the Britain approach to the pay gap is, I call it the name them and shame them, but really it's measure and publicize and be shamed by the media. So they, in Britain, if you're above 250 employees, I believe, you have to measure your absolute pay gap and publicize it. And then, you know, that's being scrutinized by the media, maybe not surprising. Ryanair was one of the, you know, top with the biggest pay gaps. So was the financial institutions, but then you have something like a Lingerie group, you know, being very high there on there. So all of that is happening. And against that backdrop of this increasing both legal pressure, but also social pressure towards fixing your pay equity problems, an organization might face, okay, you know, I want to make sure that I don't have a pay gap. And if I have a pay gap, I want to close it. So in this context, we are going to be talking about the adjusted pay gap. So accounting for all of the factors that should drive pay, are there any differences between the genders? And the standardized approach to that is running a regression to measure the gap. And this work of ours that takes this decision-driven approach to the gender pay gap is related to a lot of different literatures. Obviously, there's like a vast literature on the gender pay gap, why it happens, etc. But to the best of our knowledge, at least, we are the first to take this kind of optimization approach to fixing pay gaps. So how do we measure it? We measure a pay gap using a log linear regression. So what we do is that we have for all of our employees. So now we are an organization. We are going to fix our pay gaps. So we collect our data on all of our employees. And then for each employee, I have their wages. And then I collect the information about their job and all the other factors that should drive pay. So if I'm an organization that says, oh, we are really performance driven, hopefully I have some data on performance that I can then include and take into account when determining whether there's any gender bias. If I am an organization where part of my workforce is on union contracts, you know, we can bake that in, for example. So whatever it is for our organization that should determine pay, we include in that big X. And in that big X, let's include a gender factor. So to keep things simple, let's for now just focus on the gender pay gap. So we have all these factors that should determine pay plus the female factor. Then to get rid of the log, let's just do a substitution. So now this typical regression formula that hopefully we're all familiar with. And then we know from that we can get our regression coefficients. And in particular, we get the gender coefficient, our beta female, my F there stands for female. And I can literally calculate, after accounting for everything else in the model, is there something that is only contributed? Is there an impact on pay that's only contributed because the employee is a female? And that's a function of this linear combination of all the terms in the regression and my Y. So that's the measurement piece. So then, okay, let's say we found we have a problem. So then we need to close the gap, right? So here we have my just the beta coefficient. So this is now my gender pay gap that I want to close. And I can just write that out as a linear sum of this combination of all the data in the regression and then the log of the wages. So an important here is that before I mentioned that my WI, those are my wages of my employees, and now I add this delta. So we need to fix this pay gap. Okay, how do we fix a pay gap? Well, somebody needs to get a raise. So let my delta I then be my salary increase for that employee. So then we can reduce that pay gap and hopefully make it above some target. And in my mind, that target should always be 0, but that's a longer conversation. And then let's add a constraint that our raises are all positive. I would say typically in the real world, I have yet to meet an HR manager or comp manager or CEO that actually wants to go the other route. I've once been asked whom to fire. I think the CEO was kidding, but in real life, reducing salaries of overpaid employees is just not in the feasible set. So let's stick to that these raises need to be positive. So then, okay, I have my constraints, right? I want to meet my, pay gap target, 0 in my mind. We are going to allocate raises that are non-negative. And then, okay, I'm an organization, I'm trying to close this, one objective that then measures how good these allocations are is just to minimize the sum of the raises, right? So, so then we have this, in my mind, pretty beautiful optimization problem. So then it happens to be non-linear, but it's easily solvable. So we can solve this optimization problem, fix our pay gap, etc. But then the question is, okay, if I do that, if I take this optimization approach to close my pay gap, who are the ones that actually get the raises? So in order to understand whether this leads to a good allocation, right? So I solved the problem, I closed the pay gap. The question is, is my solution any good? If we want to understand, okay, what is driving, who gets these raises, we need to dig a little bit deeper. And what we need to dig into is each employee's impact on the pay gap. So we call that differential influence. Really what it is just the notion of, okay, what's my impact on the measurement, my beta female, if I wiggle a little bit the wages, right? So what is my impact on the pay gap if you give me a little bit of a raise? And we can calculate that, and that's this CIF. This is this linear combination of terms from our regression divided by my wages. So that's our first hint. Okay, if we follow my optimization approach that I have suggested to closing these pay gaps, who are the ones who will get these raises? Well, in particular, it will be those with lower wages, literally because you get more bang for your buck. So if you think about the measurement, in that regression formula, we are taking the log. So the fact that somebody, if you have 2 employees, one has that are the same, but one has lower wages, then if I give the one with the lower wages $1 raise, that's a higher percentage, so it will have more impact on that beta measurement. So that's the first big takeaway of, okay, who gets the raises? It's the those with lower wages. But we also have this CIF on top. And if you think about, okay, what does this CIF represent? Is this linear combination of terms that's very complex, and we spent some time trying to tease apart the CIF to try to understand, okay, who will our algorithm favor if we apply it? That turns out to be almost impossible. At least we didn't find a way, but we can play some linear algebra tricks to figure this out. So if you bear with me, we can calculate some regression residuals. So first, from regressing the log of ages on all the controls, leaving out the female indicator, and then from regressing the female indicator on all the other controls, and then thinking very far behind to our linear algebra books, we have this formula that links these residuals, the partial residuals, together. And what is important here is that here I have beta F, my measurement. So what I can do is I can isolate my beta female here, my pay gap, and rewrite the optimization. So this was my original optimization problem. All I'm going to do is, instead of looking at this here, I'm just going to rewrite beta F. And then we have this equivalent optimization problem. And why am I doing that? Because it's easier to understand what is influencing each member's impact on the pay gap and not understanding each employee's impact on the pay gap. And in particular, what I want to focus on is this factor here, which is the residuals when we try to predict the gender using all the other factors. So what do we mean? So if you think about the gender in this data, so if you think back to like when I began, right? So we had all the wages, and then we had our X, which was all the factors that should matter, and in there was our gender. The way we coded gender in that regression was that 1 was female and 0 was male. And what these partial residuals are, they are literally just me taking all of those other factors and trying to predict the gender of the employee. So then, if you buy that, that is the case, then it's interesting to think about, okay, who has really big partial residuals? So if 1 is female and 0 is male, then if I'm a female and I give you my data and the model predicts, oh, I'm most likely a male, that will be a very big partial residual, right? Because I'm a female, but you predict something really close to 0, so that will be a bigger number, right? So in other words, if I give you somebody's data and it says, oh, this is somebody with a PhD in electrical engineering, works on the trading floor of our bank, has X many years of experience, and that's a stereotypical male, but it turns out to be a female, that will be an employee that will have a lot of impact on your pay gap. So that's our second proposition when we looked into this approach, was that females that look like male in terms of their role and their traits within an organization, they will have a really big impact on the pay gap. And then similarly, if you think about and I play a little bit with this notion, if I give you some data about somebody's employee or about an employee, right? And it's again somebody with electrical engineering, PhD in a role that is very stereotypically male, and you think, I mean, it's so male that you would almost, bet your house on it that this is a data from someone who is a male employee. If that turns out to be true, what happens is that you can over predict the 0. So if I take a step back about these partial residuals, we are using a linear regression to predict a binary outcome. And the biggest reason why we do that with the logistic regression and not regression is because logistic regression doesn't overshoot. But because I'm doing this with a linear regression, if somebody is so stereotypically male, then we might overshoot. So the actual gender of that gentleman is 0, but the data is so manly, the regression model is so sure that this is a man that we overshoot. So then your partial residual will be 0, minus minus something negative, so it actually turns positive. All of that to say is that when we think about each employee's impact on the pay gap, you can actually find men that are so manly in their traits that they impact the pay gap in a positive manner. So we give them a raise and they actually reduce the pay gap. This is very counterintuitive. If I summarize then that all together is that when we think about if I take my algorithm, I can prove that it's mathematically optimal and the cheapest way to close the pay gap. Who will benefit? Low-wage workers will benefit. Females that look like men will benefit. And then there might be one or two very manly men that might benefit as well. So then the question is, okay, is that a good way to close the pay gap? And in the interest of time, I'm going to skip these simulations, but just to say that, yeah, the math works out and is pretty. But if I just reword was one comp manager told me was, there's absolutely no way that I'm going to give somebody a raise just because you tell me it's cheap. So, and what these analyses of this optimization algorithm shows you that if that's the only thing you care about is just closing this measurement, you can end up giving raises to employees that don't deserve it. And again, it kind of goes back to that very beginning, and that's why I started this talk talking about, okay, how do we think about algorithmic fairness in the context of people analytics, is that if we just take, oh, let's take this awesome optimization algorithm and close the gap and be done with it, it would not improve your pay structure. It would not increase the fairness of the pay structure. So really, it's a non-starter. So then the question is, now you spent 20 minutes talking about the math of the optimization problem, and now you're telling me it's a non-starter. How are you going to fix it? So maybe I can take 5 minutes and talk about, okay, how do we fix this? How do we recast this problem, kind of the notion of fairness, and then how do we close these pay gaps? The math is not as beautiful, but practically speaking, it can solve the organizational problems that we face. So I'm going to start here with this figure because I think for me, having been working on similar problems for half a decade now, this was a big aha moment for me. So when we think about, who each employee's impact on the pay gap, you would think if somebody is underpaid, they must impact the pay gap a lot. And the short answer is absolutely not, and it's almost not correlated. And that's what this figure here, which is from a real organization, is showing us. So what I have on the x-axis is each employee's impact on the pay gap for the same race. So we can see on the right, I have mostly the females. So this is an organization where the gap is against the females. Here on the left, I have mostly the men. So if I give them a raise, mostly it will make matters worse. And here I have the zero line. And what is interesting is that, for example, I can find females that are such in their traits, if I give them a raise, it will increase the pay gap. And the same thing, so this triangle right here is an example of a male that is such that if I give him a raise, it will reduce the pay gap. And the other important takeaway from this figure is that my y-axis here is whether the regression model that we run to estimate the pay gap thinks the employee is overpaid or underpaid. And what is the key takeaway here is that there's almost no correlation. So there's almost no correlation between whether or not an employee is underpaid and their impact on the pay gap. So if you start to think about and transition from, let's, write a really cool optimization algorithm to actually think about this in the context of algorithmic fairness, and if we agree that underpayment, has correlation with fairness, we can see that there's this really no connection between each employee's impact on the pay gap and this notion of fairness. So that was a big kind of takeaway, plus the input from the HR managers. So what do we need to do? So we really took a 3-step process to try to solve this for organizations. So I'm going to go a little bit fast over some of the slides, but I'm going to try to hit the key messages. So the first one is that if we want to apply an algorithmic approach to fixing pay gaps within an organization, first we need to adapt to the operational realities. So that includes, salary ranges, union contracts, no race lists, etc., including maximum race limits. So typically an organization does not want to increase the salaries of any one employee beyond a degree. So this is typically, we can implement this, we can just add constraints to our optimization problems and be done with it, and usually is quite easy to implement. And it doesn't affect the cost of closing the gap that much. The second is incorporating this notion of fairness. And this is where things get tricky, right? Because when we think about fairness, fairness is not a statistical property, so we need to define it. And then the question is, okay, how do we define fairness? The approach we have taken is to combine both underpayment and the bias distribution of the organization and try to correct the pay structure accordingly. And the way you can do this and then incorporate it into your optimization model is, you can do this in different ways. You can try to maximize the fairness. You can restrict the minimum fairness. Another important kind of, especially from a legal risk, is minimizing pairwise discrepancies. So if you have 2 employees who are doing substantially similar work, you want to limit the discrepancies in pay. I mean, the variability is okay. This is not about everybody should be get the same pay, but you want to minimize the regulatory risk. And I'm going to skip this. And then is the understanding the biases. So what do I mean by understanding the biases? So I'm going to close off this part by telling you this one story that really drove how we now model biases. So with one of our early partners in this, this was an organization that was really all in when it came to, equality and diversity and inclusion. We're talking about an organization that had someone come in and rename their meeting rooms to be more gender neutral. So think about someone who's all in when it comes to gender equality. And what we found when we ran the analysis on their data was that high-performing females were not being compensated to the same extent for their outstanding performance as were high-performing men. So yes, the high-performing females were being paid above average, but not to the top like the men were. And why is this important? It highlights why we end up in these places. So why do we end up with organizations with really big pay gaps? It's not because organizations don't have the right intention. It's because these unconscious biases can creep in very subtle ways. And this was really an aha moment for this HR manager that's like, decades ahead of us in gender equality. So so what this demonstrated to me was that the bias, so when we measure these problems and we understand these biases, the bias isn't equally distributed. The stereotypical example is that, maybe in the HR department, the females there are not facing much bias, but the females in the finance department are facing a lot of bias. So when we take this approach and this algorithmic fairness approach to closing these pay gaps, we need to take this into account. And the way we can take this into account is to break down the impact of each factor. So whether it's your department, whether it's age and tenure. So a typical problem that we encounter many times with organizations is that tenure matters for men, but matters less for females. So we can take this decomposition approach to understand where the biases lie, and then we try to correct those as a part of the optimization problem. So I'm going to, because I want to leave time for questions, so we're going to leave out the real world example. But here's, at the core of it, what we need to do. If we want to solve this problem with analytics, we need to adapt it to operational realities. We need to incorporate fairness and define what does fairness mean for my organization. And we need to understand and correct biases. So with that, I'm going to skip all of this and just hand it over to Twy and see if there are any questions.
Thank you, Margaret, for sharing your thoughts on people analytics and demographic pay gaps. Very informative session, and we definitely have a long way to go. So we're now open for questions. Any questions, please put it on the chat box or raise your hand, and we are here to answer your questions. Okay, I have a couple of questions. So I really like the way you concluded the first part of your presentation by reinforcing the thought that we should not blindly rely on data-driven decisions. And the quote on our retrospective data does not represent the future that we want to build. So building on this data-based decisions, they typically look at historical data to feed decision models. And it can be the case that where these data come from, they are from a non-diverse workforce because they have been collected historically. So what can we do now? What are your thoughts to ensure that we make a much more informed data-driven decisions to reflect equitable outcomes for underrepresented demographic groups?
Yeah, I mean, I think it's a complex question, but I can tell you where to start. So, I mean, one obvious way is to understand that when we have imbalanced data, it will lead to, unequal outcomes when we train our models, and that's a mathematical fact. So then if we kind of use that as our starting point, then we can start to have the conversation, okay, how do we deal with it? One way to deal with it is to understand what are the data limitations. So if we, using stereotypes, and we think about, for example, okay, who has managerial potential, right? And then if in the past all our managers that have gone through are male, and then we use that to understand, okay, what are the features that describe, future managers, and we just then apply that now to our more diverse group, it will mostly pick on males, and because of two things, right? One thing is that what is a successful male manager might look very different from what is a successful female manager, or any minority, pick your favorite, right? So then we need to pause and think, am I collecting all the important pieces of information that describe good managers, right? So we need to broaden the question from just, what was the description of a successful manager in the past, and apply that to the present. And another, just a practical, so if you think about just a practical way to address this is, create a bias dashboard. So once you build your model, we know that the data is not going to be perfect, but then look at, okay, if we kind of stick to this example of trying to identify employees who are candidates for future management position, let's run this model, and then let's identify, okay, what fraction of the male and female or, racial groups did it select into the training pool or ask the potential? And if that's biased, let's fix it. And then it depends on how we want to fix it. You know, sometimes it's just inflating scores. It can boil down to that. Sometimes there are reasons like, you know, and then we might not inflate the scores the same, but, you know, start there. Start with studying how well is your model performing. And if it isn't performing up to standards, let's fix it.
That's interesting. So it could be like we can penalize a particular characteristic which may bias the results. Is that a way to look at it?
Or you can say, I don't have the information about what makes, I have imperfect information about what makes a successful manager, right? And I know I have better information about a certain demographic group. I don't have good information about other demographic groups. What I do know is that all my employees, there's no reason to think my recruiting practices are such that, you know, a certain group has more potential than another. So then if I can't capture that in my data, then I wouldn't call it penalizing, but let's lift up those where we don't have good information.
That makes sense. Thank you for that. So we have a question.
I like to put a positive spin on things rather than a negative. Yeah.
So we have a question from Jessica in the chat box. So thoughts on a trade-off between seeking fairness across different attributes. Does decreasing the pay gap for women consequently increase it for African Americans or other underrepresented groups? Put differently, have you seen such a trade-off in practice in your experience?
Yeah, I mean, I've seen a lot in practice. So the key, so often when we apply these analytics, we're applying them at a large scale. And when we think about intersectionality, you know, race and gender, the key thing is to look at the intersectionality so what do I mean by that? When we think about our regression model, and now we're moving away from just looking at gender, right? Because we want to look at both gender and race. And then the first thing that we might do is to put in a gender variable and put in a race variable and then run the analysis. The problem with that, if we then take an algorithmic approach to fixing the problem, is that we might be just fixing it for pockets of the population while leaving others out. So a critical thing when we apply these ideas with multiple demographics is to look at intersectionalities, because that's when we make sure that we are not helping out just a fraction or one pocket of our employees, but really trying to fix the pay structure across the organization.
Thank you. Thank you for that clarification. Our next question is from Michael Johnson. Could you tell us of your experiences with HR departments who encounter your work? Are you asking them to trust a sophisticated model they know a little bit about?
No, I think transparency is key. With my other hat on, not my academic hat, my entrepreneur hat, we have baked this into a cloud platform where we make this very transparent. So you can drill into every salary decisions, every suggestion, look at the impact on the pay structure, etc. So no, I don't think we should ask whether it's the HR department or the comp department to trust any HR algorithm blindly. We should be thinking about how do we provide transparency into the benefit of applying these methods.
So data plus transparency is equal to the best decisions.
Hopefully. Sure. Yeah.
So I do see a raised hand from David Hernandez. David, you can unmute yourself and ask your question.
Okay, thank you. Hi, Margaret. Thank you very much for the talk. It was very interesting. I had a question about, well, in my organization, we try to do a bit of a pay gap, gender pay equality study, and we found this resistance and this like phrase of meritocracy, like always is the gap is explained because this particular person has this skill or this other skill that kind of took the wins out of the project, because all of the issues that we raise, they try to have these like arguments because why they were wrong, or why there were these bigger gaps in some places. In your experience, how can you like work around these kind of arguments? Because in at least in my country, this idea of meritocracy and you get paid because what you work for, your like performance, is like really one of all, like the old argument that that it's used to counter these things of equality or diversity in general.
Yeah. Yeah, I mean, when the top, yeah. So let me make a couple of suggestions. So I think in general, if you think about pay equity, it cannot be explained away by this person has this feature. So if it's really, based on performance or contribution, I think the key to try to win them on board. So is then, okay, if our compensation decisions are based on these factors, well then those are probably documented. If not, that's the first part. And then let's include them. So if it's, in my academic institution, if it's the number of A publication, well, let's count the A publications and put them in the formula. Or if it's, this quantifiable skill, let's include all of that into the model. And that's one way to try to move kind of towards acknowledging that even after accounting for all these factors that should drive pay, that there are biases. I realize that can be difficult in some cases and obstacles, but that's what I would suggest. So I can reflect on some of the things that I have observed. So I'm lucky enough to have been born in Iceland, and we tend to score and rank on top for gender equality. And 5 years back, we set new laws that required organizations to get an equal pay verification. And one of the biggest changes that happened, so to get this verification, organization had to have a quality system around their compensation decisions. And one of those was actually to write down a justification for whatever decision was being made. Just that, having to write down a reason for the raise started to make these decisions more objective. So, you no longer could write down, well, he's so funny at the water cooler. You really had to, support your decisions with quantitative or, or qualitative argument that would hold up. So simple things like that can be a step in the right direction. But I hear you. If the top management is not on board and does not acknowledge that, there are inequities, baby steps are probably the way to go. And then that starts by trying to collect the data that then should explain these, why somebody's getting a higher pay than another. Try to take that into account and then try to go from there.
Thank you.
Thank you, Margaret. I think we are out of time, but probably we can take one more question if that's okay.
Sure.
Yeah, we have a question from Adrianto. How do you standardize performance metrics for an organization with heterogeneous jobs when building the model? So how do you account for differences across different kinds of jobs?
Yeah. I mean, we can play our usual tricks. So, for example, if you think about our performance data, obviously we need to think about, okay, to begin with, is it skewed? Sometimes it is. Increasingly, it's becoming better quality. But what I think this question is about, okay, what if the performance for a certain group, how it's measured and how it should impact pay, is very different than from another group. And I would almost say, okay, let's have different metrics for those two different groups, but we can still then put in both into our measurement part. So, if our blue colors are measured very differently, that's how I would capture it and deal with it. I was literally, if they're not like, if putting them together through normalization, as the was suggested, doesn't work very well, we can keep it separate as long as the number of employees is decently large.
That makes sense. Thank you so much, Margaret, for speaking with us, for being a part of this webinar series. So before we close, I'd like to remind that next week we will have Dustin Cole presenting his research on supply chains as agents of equity and inclusion within communities. So please join this session and please spread the word among your academic and professional network. Thank you again for joining us. Thanks a lot.
Thank you for having me.
Thank you, Margaret.